There's a city on the coast of South America where for half the year, the sun can disappear for weeks at a time. Lima sits in the tropics. It's closer to the equator than Hawaii is. By rights, it should be hot and bright. It isn't. From roughly May to November, a flat gray lid of clouds slides over the city and simply stays there, week after week. Locals have a name for it. They call it the donkey's belly. This winter, the lid lifted. In June, parts of Lima were 5 to 6 degrees warmer than normal, with afternoon temperatures approaching 90 degrees Fahrenheit or 30 degrees Celsius. Centuries ago, fishermen on that same coast noticed something similar happening every few years, and they gave it a name too. They called it the boy child, El Niño. They noticed because the sea turned warm, the fish disappeared, and their families went hungry. They had no idea what they had actually found. That warm water is the visible edge of the largest disruption the Earth's weather is capable of producing on its own. And right now, it is building in the Pacific faster than almost anyone expected. It has already emptied Peru's nets. It has already made India's monsoon stagger. And it is heading for a planet that is hotter than any point we've ever measured. So how does a patch of warm water in a part of the ocean almost nobody will ever see end up deciding what happens on your street? Why is this one different from all 5 that came before it? Finally, and most importantly, what will it do to our entire planet in 2026? Picture the Pacific Ocean as a large bathtub. Under normal conditions in the tropical Pacific, trade winds blow from east to west, pushing warm surface water toward Asia and Australia and allowing cold, nutrient-rich water to rise up along the South American coast. That's the baseline state of the Pacific. Warm water in the west, cooler water in the east. El Niño happens when those trade winds weaken. The warm water piled up in the west slides back east across the entire ocean and settles over the cold water of South America like a lid. The upwelling stops, the fish leave, and the sun comes out over places like Lima. If it ended there, this would be a local story about fishing. It doesn't end there, and the reason is thunderstorms. Warm water evaporates, evaporating water rises, and rising water builds thunderstorms. So wherever the warmest water in the Pacific happens to sit, an enormous column of rising air sits above it, pumping heat from the ocean up into the sky. That column is one of the most powerful things on Earth. And the jet streams, those high-altitude winds that steer storms across entire continents, are anchored to it. Move the warm water, and you move the column. Move the column, and you move the weather. Not just over the Pacific, but over India, over Africa, and over the Atlantic. So the question was never whether this would happen, it was how far the water had slid and how fast. Scientists watch one particular patch of the Central Pacific the way a doctor watches a heart monitor, and right now that patch is running about 1.2 degrees Celsius warmer than normal, and still climbing. A degree doesn't sound like much, but water is stubborn, and it takes a colossal amount of energy to warm it. So heating a stretch of ocean, roughly the size of the United States by a single degree, means an amount of stored heat that is genuinely difficult to hold in your head. But here's the thing, the number that actually convinced forecasters this month wasn't a temperature at all. NOAA reported that thunderstorms are now firing up over the central and eastern Pacific and dying down over Indonesia, which means the column of rising air has physically moved. That is not a projection, that is a measurement. The ocean is no longer just warm, and the sky has agreed with it. Which is why the language changed. NOAA now predicts that this becomes a very strong event between October and December, one that would rank among the biggest since records began in 1950. Events of this size are rare. There have only been 5 since 1950, and 2 more are suspected much farther back, in 1888 and in 1877, long before anyone had the tools to see them coming. That last part turns out to matter more than you think. The first place a Pacific El Niño lands is the coast the Pacific touches, and it already has. Peru's anchovy fishery is the largest single-species fishery in the world. Those fish get ground down into fish meal, which feeds farmed salmon, chickens, and pigs across dozens of countries. So most people have never heard of it, and most people eat something that depends on it. And when the cold water stops rising, the food stops arriving, and the anchovies either die or go looking deep, which is why Peruvian crews have been finding them more than 100 meters down, hiding in whatever cold is left. Watch how fast this moved. Peru set this season's catch limit at 1.9 million tons, the lowest in 10 years, and more than a third below last year's. By early June, boats had brought in only about a quarter of even that reduced target, and over half of what they caught were juveniles, fish too young to have bred, which is how you lose next year as well as this one. So on the 11th of June, the same day NOAA officially declared El Niño, Peru shut the season down to save what was left. The next link feeds about a fifth of everyone alive. India's monsoon and El Niño have a long and unhappy history, because when that column of rising air abandons Indonesia and drifts east, the wind pattern that hauls moisture onto India weakens with it. India's weather service knew this and cut its seasonal forecast to below normal before the season had even started. June turned out to be worse than the forecast. India ended the month roughly 41% short of its usual rain, which isn't a slow month, it is a season in trouble. And then in the first week of July, it poured. A run of storm systems rolled in. The monsoon came roaring back, and that 41% shortfall collapsed to about 15% in 8 days, bringing floods, landslides, and red alerts with it. If you only saw one of those 2 headlines, you saw the wrong monsoon, because this is exactly what El Niño does to India. It rarely turns the rain off. It makes the rain lurch, with long dry stretches, then a violent burst, then dry again. And forecasters called the next pause for the middle of July, as El Niño strengthened further. And for a farmer, the seasonal total is almost meaningless, because rain that shows up in the wrong week doesn't save a crop. It drowns it, and then leaves it to bake. There's one more thing missing this year. India has a second climate pattern out in the Indian Ocean that can sometimes push back against El Niño and drag moisture in anyway. And it has rescued the monsoon before. This year, it is sitting neutral, doing nothing. There is no counterweight. Europe has just been through something without precedent. Western Europe recorded its hottest June ever measured. France had its hottest day in its entire history. Germany broke its national record, and Barcelona hit 40.5 degrees on the 8th of July. The estimated death toll runs into the thousands, and the story wrote itself, because a record Pacific and a record Europe in the same summer are obviously connected. Except they aren't. When researchers ran simulations on this heat wave, the answer came clean. El Niño played no role. Europe's heat was a heat dome, parked over the fastest warming continent on the planet now about 2 degrees hotter than it was in 1976. So why does this matter for our story? Because it tells you when El Niño's bill actually comes due. This event was declared only 5 weeks ago, and its grip on the northern half of the world doesn't show up in summer. It shows up in autumn, in winter, and in the year that follows. Europe's June heat wave wasn't El Niño. It was the floor that El Niño is about to be stacked on top of, and Europe's El Niño hasn't happened yet. Here's something that surprises most people when they first hear it. A super El Niño actually makes the Atlantic hurricane season quieter. not safer everywhere, but quieter in the Atlantic. When the Pacific Ocean heats up dramatically, it changes wind patterns high up in the atmosphere over the Atlantic and Caribbean. Those winds create what meteorologists call wind shear. There are powerful gusts at high altitude that tear developing hurricanes apart before they can grow into anything serious. Hurricanes need calm, consistent conditions to strengthen. Wind shear is their enemy, and a strong El Niño fills the Atlantic with it. This is why NOAA's outlook called for a below-normal Atlantic season, and why Colorado State University cut its forecast in June to around 11 named storms, roughly 60% of a normal year. But here's the catch. The Pacific gets the opposite. El Niño warms the eastern Pacific, reduces wind shear there, and creates ideal conditions for storms to develop and strengthen off the coast of Mexico and Central America. So while one ocean calms down, the other heats up. The Atlantic quietens, the Pacific intensifies. And whether that trade-off works in your favor depends entirely on which coastline you call home. This is the part that actually matters for most people watching this, because a super El Niño doesn't feel the same everywhere. Depending on where you live, it either brings too much water or not nearly enough, and understanding which side of that line you're on is the key. Start with North America, where the effects depend heavily on where you are, and where almost nothing lands until winter. The southern United States, from California across Texas to Florida, typically turns wetter and cooler, as a more active jet stream drags storm after storm across the region, which for a drought-stricken Southwest is mostly welcome, and for low-lying areas means flooding. The northern tier does the opposite. The Pacific Northwest and the Northern Rockies run warmer and drier, with reduced mountain snowpack, and that thin snow matters more than it sounds, because it's a water supply released slowly through the summer, so losing it dries everything downstream out faster and stretches the wildfire season. The upper Midwest generally gets a milder winter, several degrees above normal. Up in Canada, the same split holds. The western provinces tend to run warmer and dry, which raises drought and fire risk across the prairies and British Columbia, while the effect fades the further east you go. The eastern African regions, including Kenya, Somalia, and Ethiopia, typically see above-average rainfall during El Niño, which sounds like good news until you see what that actually looks like on the ground. The 2023 to 2024 El Niño, which wasn't even a super event, caused devastating floods across the region that displaced hundreds of thousands of people. South America has already been introduced through Peru, but the damage doesn't stop at the coast. The Amazon basin faces drought and heat, which is dangerous in a rainforest already under enormous pressure, since a large share of it is degraded, and a strong El Niño on top of that raises wildfire risk toward the levels of the catastrophic 2023 fire season. Further south, Argentina, Uruguay, and southern Brazil tend to get the reverse, with above-average rainfall and a raised risk of flooding in low-lying areas. Australia is the clearest signal of them all. El Niño and Australia are tightly linked because the warm water sliding east across the Pacific is warm water sliding away from Australia, taking its rainfall with it. That means a hotter, drier spring and summer across the east of the country, shrinking water supplies, stressed farmland, and a longer, more dangerous bushfire season. Beyond the floods and droughts and hurricanes, there's a bigger thing that makes this different from every event that came before it. All 5 of those previous giants arrived on a cooler planet, and this one is arriving on a world that has just posted its 11 warmest years in a row. El Niño doesn't create heat, it moves it. For years, the Pacific quietly stores heat below its surface. El Niño releases heat that the ocean has been storing for years back into the atmosphere. That process consistently pushes global temperatures upward. But the only difference is the starting point or the baseline. The planet is already warmer than it's ever been in the modern record, So when El Niño adds its heat on top of that, the numbers go somewhere new. So where does all this leave us? This is not a prophecy, it's a control experiment. The ocean is doing the same thing it has always done. The difference is that people in 1877 and 1950 never saw it coming, and we can. This is one of the very few global catastrophes that announce itself months in advance, on a chart that updates every single week. The UN asked for money before the drought. India updated emergency plans for 262 districts before the monsoon faltered. Peru pulled its boats off the water before the fishery collapsed. The Pacific hasn't done anything strange. It does this every few years. What's new for the first time in the whole of human history is that we get to watch the chain fall link by link and reach the end of it before it does. Before you go, I want to hear from your corner of the map, whether it's a strange season, a failed rain, a warm winter, or a coast that isn't behaving the way it should. Drop in the comments, because between all of you watching, you cover more of this planet than any single forecast ever could. And if you want to step off this planet for a moment, we recently uncovered what's happening deep inside Mars, where the ground itself won't stop shaking. If you missed that episode, it's right on your screen. See you in the next one.